For your response. Students, this is Ankit Joshi. I welcome you all on India's largest e-learning platform, BYJU'S Exam Prep. Am I audible to all of you? Just need your response. So today we are going to discuss about continuous time Fourier transform. So students, continuous time Fourier transform is the part of this AIMER'S series course. The particular very important topic from signals and systems. And on your screen you can see a brief introduction about me. Students, as you know, my name is Ankit Joshi and I have been teaching in this domain since many years. Yes, my subjects of interest are analog circuits, signals and system, engineering mathematics. Student, GATE AIMER'S series is already on, started from 14th of November, and this particular session is the part of this series only, and here I am taking up your signals and system. Tomorrow, 4th of December, 12:30 noon, don't forget to join session from Abhinav Negi Sir, and this session will be streamed on BYJU'S Exam Prep. This is our app, BYJU'S app for GATE and ECE students, and here he will be giving you some golden rules, some tips, score or how to score a single digit rank in any GATE exam. Then in the description of this session, the link is given for GATE and ECE test series. Students, don't forget, copy that link, explore it, and you will find that this link is beneficial for you. Test series is students. This test series is having various features. 60 plus tests. This test series is prepared by GATE experts. Detailed mock analysis is there, and you will be able to find your rank at all India level. Virtual scientific calculator is also implemented with this. 4,000 plus practice questions are there overall, covered by this test. Students, let us first discuss about the properties of Fourier transform. Before discussing the properties of Fourier transform, I'll tell you the definition of Fourier transform. Students, if you are having a signal x of t which is continuous in time domain and aperiodic, then to see its spectrum you need to calculate this Fourier transform. Continuous time Fourier transform. This continuous time Fourier transform is denoted by x of omega. X of omega will be continuous in frequency, thus this will be aperiodic. Okay, so let us define this x of omega. X of omega is Fourier transform of x of t, and this is from minus infinity to x of t e raised to minus j omega t dt. Format, this is the formula, this is the definition of Fourier transform. Okay, here F stands for Fourier transform operator, continuous time Fourier transform operator. X of t is the signal in time domain and x of omega is the frequency response or frequency spectrum or the function in the frequency domain. Okay, time domain representation and frequency domain representation. Now students, very first property is the linearity property. What is this linearity property? If you are having a signal x1t whose Fourier transform is denoted by x1 omega, another signal x2t whose Fourier transform is denoted by x2 omega, then when you take the combination, linear combination of these two signals, a1 x1t plus a2 x2t, then The resultant Fourier transform will be a1 x1 omega into a2 x2 omega plus a2 x2 omega. This is the linearity property. Then after linearity property, we have time shifting property. So if x of t is having Fourier transform x of omega, if this x of t, in this x of t is this t is delayed by a, then its Fourier transform x of omega will get multiplied by complex exponential term minus j omega t. Students, frequency shifting property. If x of t is having Fourier transform x of omega, and this x of t is multiplied by e raised to j omega naught t, then omega will be delayed by omega naught. And when this is multiplied by e raised to minus j omega naught, omega will become omega plus omega naught. This is frequency shifting property. Comfortable? In time domain, if time domain signal x of t is multiplied by complex exponential term, the frequency domain signal will be delayed by omega naught. Time scaling property, very important. If x of t is multiplied by x of omega, and if you are doing a time scaling, in x of t, then what happens? Time scaling property says that it is 1 upon mod of a x of omega by a. Compression in time domain corresponds to expansion in frequency domain, and expansion in time domain corresponds to compression in frequency domain. Okay? When there is folding in time domain, it corresponds to folding in frequency domain. So it means reversal in time domain corresponds to reversal in frequency domain. Duality property is very important. If x of t is having CTFT x of omega, now this capital X of omega, in this capital X of omega, if omega is replaced by t, in this x of omega, if omega is replaced by t, then definitely you will be getting a time domain function. Students, I am not getting any responses from you. All fine? Can I have your response? So in this x of omega, if omega is replaced by t, then what happens on the right hand side? It is 2 pi times, in this small x of t, t will be replaced by minus omega. Yes, sir. Now here, x of t is having Fourier transform x of omega. d by dt x of t having transform j omega x of when there is differentiation in time domain of omega gets multiplied by j omega. That's frequency differentiation property. X of t is having Fourier transform x omega, and see here differentiation in frequency domain. What happens in time domain? X of t gets multiplied by minus. When there is convolution in time domain, it corresponds to multiplication in frequency domain. Right. And when there is multiplication in time domain, it corresponds to convolution in frequency domain. Multiplication in time domain corresponds to convolution in frequency. This property is very, very important. See here. X of t is having Fourier transform x of omega. By definition of Fourier transform, x of omega is minus infinity to infinity x of t e raised to minus j omega t dt. Put omega equal to 0. So x of 0 will be minus infinity to infinity x of t dt. So can we say that this is area under the signal x of t? Yes, sir. This is area under the signal x of t. So area under signal x of t is nothing but value of the spectrum at omega equal to 0. Here. Then what is the formula for inverse Fourier transform? It is x of t 1 by 2 pi integration from minus infinity to infinity x of omega e raised to j omega t d. In this function, if you put t equal to 0, you will get x of 0 equal to 1 by 2 pi x of omega d omega. So we can say that area under the spectrum minus infinity to infinity x of omega d omega. This will be 2 pi times small x of 0. Parseval's energy theorem. This one is really very important. If x of t is having Fourier transform, if x of t is having Fourier transform x of omega, then energy of the signal x of t minus infinity to infinity x of t modulus square dt. And the same can be obtained from the spectrum by using this format 1 by 2 pi minus infinity to infinity x of omega modulus square d omega. Is that clear? Let's check it once. Come on, respond here. Now based on these properties, we'll solve some very basic level questions. First, x of t is having Fourier transform x of omega. There is a signal y of t which is 5 times x of 3t minus 2. Hanji, 5 times x of 3t minus 2. So we will start with x of t. In this x of t, we are delaying by 2 units. We will get x of t minus 2. Then we can time scale by a factor of 3. We will get x of 3t minus 2. Then we do amplitude scaling factor of 5. Get 5 times x of 3t minus 2. Okay. So x of t is Fourier transform is x of omega. When you delay by 2, x of omega gets multiplied by exponential term e raised to minus j 2 omega. Time scaling by 3, it will be 1 by 3 and omega will be replaced by omega by 3. And amplitude scaling by 5. Just multiply by 5 both sides. Okay. And suppose in the options answers are given in terms of f, not in terms of omega. What you need to do? Inside this argument of x, wherever there is omega, replace omega straight away by f. Replace omega by f. But outside this, if you find omega, that omega should be replaced by 2 pi f. This is the Fourier transform of this phi of t. All right. X of t is having Fourier transform x of omega. Starting with x of t, advanced by 7. Time fold it. Then amplitude scaling by factor of. X of t is Fourier transform is x of omega. When it is advanced by 7, hello, when x of t is advanced by 7, what will be the impact in frequency domain? X of omega. Students, all of you must subscribe this channel, then only you will be able to comment here. E raised to j omega 7. Then it is folded. So folding in time domain corresponds to folding in frequency domain. So this omega will be replaced by minus omega. And amplitude scaling by 2, simply multiply by 2 both sides. If you are expecting the answer in f, not in omega, e raised to minus j, omega will be replaced by 2 pi f. So 14 x of minus f. Got it? Moving to the next. This one is interestingly very nice question. Just a moment. So students, we start with x of t. X of t. Then first of all, you need to realize this scaling by 1 by 3. So you will get x of t by 3. Then you need to advance by factor of 2. Then you need to time scale by factor of 5. Then you need to hold it. And finally, we need this amplitude scaling by factor. X of t is having Fourier transform omega. X of t by 3. So when you are doing time scaling by factor of 1 by 3, it should be 3 times x of 3 omega. Then what? Then advance by 2. 3 e raised to j 2 omega 3 omega. Time scaling by factor of 5. So 1 by 5 omega by 5. What we can do? Folding. So folding in time domain corresponds to folding in frequency. At last, what we can do? Here you can see that it is amplitude scaling by factor of 3. Finally, we can multiply by 3. Yes, he was already there. No? Finally, you can multiply by 3. Thank you, Rais Ahmed. Thanks a lot. Very nice of you. It's very nice of you. Wish you all the best. So students, till now we obtained 3 by 5 and all. But when you fold it, omega will be replaced by minus omega. At last, you need to do the amplitude scaling by a factor of 3. So when you multiply by 3 both sides, so here you will get 9 by 5. And at last, if omega is to be replaced by f, then here outside x you can replace by 2 pi f, but inside this argument you just replace by f. See this one. X of t is having Fourier transform x of omega. We need to find out Fourier transform x of 2t. Simply apply the property. Fourier transform of x of t by 2. 1 upon a of 2. Okay. Fourier transform of x of minus t. X of minus omega. Got it? Yes, students, kindly respond here. It appears that it is boring if no response or very less response from student side, from your side. Here, Fourier transform of x of t is x of omega. X of t minus, what will be its Fourier transform? X of t minus 3, x of omega, and it is e raised to minus g, then x of t plus 1, x of t plus 1, x of omega, e raised to j 1 omega. This is how we proceed. Next. These questions are based on frequency shifting property. So if x of t is having Fourier transform x of omega, then x of t multiplied by e raised to minus j2. Its Fourier transform will be x of omega plus 2 e raised to j5 multiplied by x of t. Its Fourier transform will be x of omega. G of t is having Fourier transform g of omega. Find the CTFT, that is continuous time Fourier transform of the signal y of t in terms of g of t. That we can. So first we will express g of t in terms of y of t. Very simple. So this is g of t. Zero to 4. Amplitude is 2. Now, what we can do, to just advance it by 2 units. When you advance it by 2 units, you will get the signal from minus 2 to 2. Amplitude is 2. So advance means g of t plus 2. Then what we want, amplitude 3, not 2. So we will multiply by 3 by 2. So y of t is 3 by 2 times g of t plus 2. Great. So we will write the Fourier transform g of t, that is g of omega. Then Fourier transform g of t plus 2 e raised to j to omega g of omega. Minus. If it is plus here, it will be minus here. Then amplitude is scaling by 3 by 2. Raised to minus j2 of omega. Omega can be replaced by f. This will be our answer. Raised to minus j45 g of f. I am having a little bit sore throat as I have taken one big session around continuously nearly 3.5 hour session for maths marathon today at 11 a.m. on our Hindi, our mechanical civil channel. So not good at throat. Then 1-2 hours class in paid domain. Delta t is having Fourier transform 1. I need to explain here. Fourier transform of 1 is 2 pi delta omega. See, delta t is having Fourier 1 by duality property. This 1 is brought to the mean. So it is 2 pi delta of minus omega. And delta of minus omega is delta omega because delta omega is even function. Now students, 1 is having Fourier transform 2 pi delta omega. If this 1 is multiplied by complex exponential term, then frequency domain there will be shifting. Right. Students, cos omega naught t, this can be written as e raised to omega naught t. plus e raised to minus j omega naught t by 2. 1 by 2 is out. What is the Fourier transform of e raised to j omega naught t? 2 pi delta omega minus omega naught plus omega. So 2 pi is taken common. Pi. I'll write this second term at first place. Get this one. Transform of cos omega naught t. I times delta omega plus omega naught plus delta omega minus omega. See, sin omega naught t. This is the formula for sin omega naught t. Take its Fourier transform. 1 by 2j out. Fourier transform of this exponential term. Fourier transform of e raised to minus j omega naught t. What happens? 1 by 2j will be out. E raised to j omega naught t will be 2 pi delta omega minus omega naught minus 2 pi delta. You can take 2 pi common, 2 to cancel, pi by j. Pi by j is minus j pi and minus is brought inside. Will be the signum t Fourier transform is 2 by j omega. How we have derived it? See, let x of t equal to signum t. X of t equal to signum of signum t will be x of omega. Okay, sir. Okay, sir. Signum t, it is 2u of t minus 1. Differentiate both sides. T is nothing but your x of t. X of t is 2u of t minus 1. Differentiate this. Derivative of u of t. Derivative of 1 is taking Fourier transform both sides. Fourier transform of x dash t. Yes, Fourier transform of x dash t. J omega x of omega. Fourier transform of u dash t. What is u dash t? Derivative of u of t is delta t. 2 as it is, delta t's derivative will be 1. X of omega will be j omega. And what is this x of omega? Fourier transform of signum t. Okay. So students, the transform of signum is 2. Hello students, stopping this session here. We'll meet in the next session on Monday with a new topic. But I can expect some more responses during the live class. No response under a bad health situation is always create a demotivation in teachers. Not demotivated, I'll come up with a better health, but expecting responses from your side. Thanks a lot for joining me. Thank you. Jai Hind, Jai Bharat.